So this is my lock controller circuit.
This is my lock controller circuit with various sub-modules used
inside to help me
the circuit.
Implement it. And this is the lock TB test bench circuit.
Lock TB test bench circuit.
With the
and so if I reset the simulation,
lock controller module inside and the various inputs attached.
And then I do simulation enabled with tick frequency at 4.1 kilohertz.
When I reset the simulation,
multiple clock cycles.
And then I set the tick frequency at 4 kilohertz to make sure that
upon power up all LEDs are off, which they should
multiple clock cycles.
And upon
I set
the user pressing S
to enabled,
the blue LED
should
turn on, which it does, and it should remain on
all the specifications detailed
until the command sequence has been completed.
So upon power up, all the LEDs are off.
And then,
so upon detecting
if
the
L is pressed immediately afterwards, then
the blue LED should turn on once S is released,
which it does.
And it does.
And then
if I press
the three
L,
digits immediately
afterwards, no intervening keys,
U or 3,
then the
1,
door
4,
should be locked.
And I press S first.
So
and I can have multiple keys in between. Then the door should unlock.
If I click S again.
S, example,
and the
3,
blue LED turns
2,
off, and
1,
then if I click S again, then
7,
the blue LED should turn on
8,
again.
And then 3, 1,
and now, for
4,
example, if
U,
I
then
do
the
not press L immediately
turns
after
off,
S, so if I click
and then the
4
door is unlocked,
and then L, then
now
the door should remain locked, but then the red LED should turn on,
whenever S is
which it does,
detected by the user, the blue LED
it should only turn off
where,
once I click S again, upon which the blue LED will turn on. So
if
I click any other key, it should just remain the same.
And now,
if I click S, then the blue LED should
L
turn on.
is not pressed immediately after S, so for example I press S,
so now
3, 4, then L,
to unlock
then
it,
the red LED should turn
S,
on, and it should remain on until S is pressed again. So if I press any intermediate buttons, it shouldn't have any effect.
1, 4.
And then similarly for U,
it
if it's not immediately preceded by 3, 1, 4, then it should not unlock. So if I lock it,
red LED should turn on if I don't. If U is not immediately preceded
3,
by
1, 2,
3, 1, 4,
and then I press U.
So if I do S,
then it should remain locked, and the red LED should turn on.
U, the red LED should turn on. It should only turn off when I click S again. And then also, to make sure that I can press multiple other keys, and then 3, 1, 4, followed by U, and it should still unlock. So I'll lock it, and then I'll click
different ways in which U can be unlocked. So
7,
if I do,
and then now if I click 3, 1, 4,
so it should be if any number of
digits
are pressed. It only matters if the 3 immediately preceding digits
which it does.
Are 3, 1, 4. So if I do like S,
and
3, 1, 4, and 3, 1, 4, then U, then it should unlock, and the LED should turn off.
In order to detect,
L should produce an error. So if I do S,
multiple key presses, and it should be invalid
U, that
in
should
that
produce
case.
An error. If
so we can turn off
S,
the
4, 4,
simulation.
L, it should
unlock. If we go to the lock
should only lock if I press S and L immediately afterwards, like this.
And then
if I press, it should unlock if I press S.
So we let it run.
4.
And then so if we do, for example, 3, so if we turn S on, and then release it, so now the blue LED turns on. So now if I turn both 3 and 4 in the same clock cycle, then it's invalid. So nothing happens, and then it's treated as an invalid key, and I release it. And so that completes the testing of the circuit.